Here's a dataset that shows the distribution of regular and nasalized vowels. You might need to pause the video to look at the dataset in totality. Now, after having looked at the dataset, here's an observation. The vowels in the right column are identical in place and height to those on the left, but they have acquired a nasal feature. This only happens when the vowel is immediately followed by a nasal consonant. For English, we only have 3 of those. In phonology, we don't like to write long, rambling sentences to describe what a sound is doing. If I say the vowel becomes nasalized whenever it occurs immediately before a nasal consonant, it's accurate, but it's inefficient. As scientists, we have a formal shorthand, a mathematical logic to map these articulatory changes. I'm going to show you how to translate that sentence into a phonological rule. Every phonological rule follows a standard template. So let's break that down. A is the underlying phoneme. This is the sound as it exists in your mental filing cabinet. It's what you see in your head. The arrow simply means becomes or is realized as. B is the allophone. This is the specific physical version of the sound that actually comes out of your mouth. The slash means in the environment of. It sets the stage for the change. The blank spot is the most important part. It represents the exact spot where the phoneme is sitting. C and D are the neighbors that trigger the change. Let's apply this to our dataset. Our target is a vowel. In notation, we use a capital V to represent any vowel. So we start with V. What does it become? It becomes a nasalized vowel, which we write as V with a tilde. So our rule so far is the vowel becomes nasalized. Now we need the Y. We add our slash, and then we ask, where does the vowel need to be? It needs to be right before a nasal consonant. In notation, we use a capital N for any nasal consonant. Since the nasal follows the vowel, we place the N after our blank spot. The final result, our completed rule, looks like this. Conclusion. This formula tells us everything we need to know. A vowel becomes nasalized in the environment of being followed by a nasal consonant. This notation allows us to see the software of the brain at work. It shows that the brain is automatically toggling the velic aperture coordinate based on the upcoming nasal target. Once you master this shorthand, you can map the entire phonological system of any language on earth with the precision of a chemical formula.